Hi students, we'll discuss one more sum in pushdown automata. The next example is obtain a PDE to accept the language L is equal to AN BN such that N is greater than or equal to 1 by a final state. Right, I should have equal number of A and B. Right, that is my language. L is equal to AN, A to the power N, B to the power N. Such that number of n is greater than or equal to 1. So here in this language, two things you have to keep in mind. By seeing the language, I understood that I should have equal number of A and B. And next is I have to follow the ordering. Suppose if I have any string like this, is it a valid string for this language? No. Why? It has equal number of A and B. Number of A is 2, number of B is 2. But what is my language? First I should have A and then followed by B. A-N, B-N. So I have to follow this ordering. That's what I told. Two things you have to keep in mind. I should have equal number of A and B. At the same time, I should follow the ordering. What is the ordering? First I should have all A's followed by B's. Right? Suppose if I have like this, it is a valid string. This is not valid, it is invalid. This is a valid string. Now for this string, I am supposed to write my pushdown automata. I am supposed to design my pushdown automata. Right? So we will start with our start state. Which is our start state? Delta of Q0. Right? What could be your first symbol? I can have only A. As I said, it is A, N, B, N. First I should have all A's, then I should have B. So my first symbol, I can have only A. If I have B, it is an invalid string. Suppose if I have like this, it is an invalid one. Though it has equal number of A and B, right? It doesn't follow this ordering. First all A followed by B. So it is an invalid one. So first symbol I can have only A. So A and stack is empty. So it is said not. So what you have to do? You have to push. So Q0, as I told, for complete A, right, I use this push operation and I push all the A's into my stack. Right, how the machine verifies whether it has equal number of A and B? Then first it will push all the A's into your stack, then one A will consider from the stack and one B from input symbol. 1, 1. One count matches. I will do with an example. Suppose if it is, by seeing this you can say it is a valid one, right? But what the machine does is, first it will push all the A's into your stack. So not 1, 2, 3, right? Then for this B it starts popping, right? It starts popping. So input symbol, if it is B, right? It will pop one A from stack. Count 1, 1 matches. Next input symbol, it pops another A from stack. 1, 1 matches. Next input symbol, another A from stack. 1, 1 matches. Now your input symbol becomes empty, stack becomes empty. If your input symbol is empty and stack is empty, what is the meaning? Right, I have reached my final state. The given string is a valid one. Right, suppose if it is like this, by seeing this string, you can say it is an invalid one because it doesn't have equal number of A and B. But how the machine finds it is an invalid string? All A's I push inside my stack, right? Then if I encounter a B, it starts popping a from stack. For this input symbol A, it pops a from stack. Next input symbol, it pops another A from stack. And it has one more input symbol B, but it doesn't have any A symbol inside my stack it has become empty. Now the condition is like input symbol is B and stack it becomes empty. Right? So you won't have any action for this. When you can reach your final state, both your input symbol and stack becomes empty. You can reach your final state and you can say I have equal number of A and B. At the same time, both input symbol and stack it should become empty. Then only you can say, right, I have equal number of A and B. But here stack becomes empty but input symbol is not empty. So you cannot say I have equal number of A and B. So the machine rejects it. Right? So we'll write the transitions. So my first symbol should be A and I be into naught and I push this A into my stack. Now what is your stack top? Stack top is A. Right? Q naught, stack top is A, and if you have one more A, right? If you have one more A, what you will do? You will be pushing this because I am pushing all the A's into my stack. A. Now you are in Q naught because my current state is Q naught, and what is your stack top? It is A. If your input symbol is B, like the previous language, it doesn't have any separator, right? It doesn't have any separator, but so when you find this input symbol B, what you have to do? You have to pop. So while popping, make a state change and then pop. Q1 and then pop. Now what is your state? Q1, delta of Q1, right? What will be your stack top? Always your stack top, it will be A. Because you have pushed only A into stack. You have not pushed any other symbols into your stack. So every time your stack top will be A. Right? A. And if your input symbol is B, what you can do? You will be in Q1 and you can pop. Input symbol is B and stack top is A, you can pop. Right, now what is your input current state? Q1. Current state is Q1, and if your input symbol is empty and if your stack top is empty, at the same time both are getting empty. So you can conclude I have equal number of A and B. So you can move to your final state, make a state change, keep this as a final state, and you can conclude. How to draw the transition diagram? Q naught, how many operations? 1, 2, 3. First is A, comma, Z naught, A, Z naught. Next is A, comma, A. Next is B, comma, A, epsilon. Sorry, this epsilon, there is a state change. Right, so it is Q1, Q0 to Q1, B, comma, A, and it is epsilon. Now I am in Q1, so it is B, comma, A, epsilon, Q1, next is Q1, Q2. This is final state. Condition is epsilon, comma, Z naught, and it is Z naught. Right. Thank you. Hope you understood it. Thank you.